Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we will discuss a concept regarding stream function. In our previous lectures, already we have discussed regarding the velocity potential function, and there we have seen that how the flow is flowing along with all these directions. Okay, like we have taken the x, y, z, three directions we have taken, and in that all directions, if you see that velocity also given u, v, and w. And what we have considered there, just I'm reminding you, this is suppose u and this is v and this is suppose w. That means this is your x, y, and this is z direction. So what we got there for this velocity potential function, how we used to write the velocity potential, the velocity component u, we used to write that is the negative derivative of this velocity potential function in the particular direction. So that was for velocity potential function. But stream function, what it says, actually it is defined a scalar function. It is a scalar function and with respect to space and time. So let me write it is a scalar function. So the previous one also same thing, scalar function, and with respect it is a function of space and time. So that the partial derivative of this, the partial derivative with respect to any direction. Suppose for this stream function, let me consider another one diagram. Suppose it is given like this, x and y direction only. Z direction also you can consider. So let me consider only for this two direction, because this will be applicable only for two-dimensional flow. Okay, so x and y direction. So what I told you, the definition. So stream function is a scalar function, okay, of space and time, such that the partial derivative with respect to directions, with respect to any directions. So either maybe x or y directions gives the velocity component at right angles to the direction. That means previously what we used to consider, the x direction means we used to consider the u velocity here, and y direction means we used to consider the v velocity here. But for this, what we will consider here, if you are considering the x direction, the velocity u will be in the y direction, and for the x direction, what is the velocity? Now that will be v. The velocity will be in the x direction and u will be in the y direction, reverse. For when you consider this one, so this velocity need to be, it will be considered the -1. So minus velocity of this u. So that means what we can write, it will be represented in a right angle. Previously what? Now which direction flow is there? In the same direction the velocity components used to identify. For this case, okay, we used to take the right angles of that particular direction. So how we used to define, let me tell you. So this stream function is to denoted by psi, okay, and this psi only will be considered in the two-dimensional flow. Keep in mind, this will be considered on the two-dimensional flow, and this psi, already I have told you this one denoted as psi. So psi we can write function of f and f, x and y. So previously for this, what we have written, a function of x, y, and z. Okay, this is for the steady one. Okay, and steady case means we need to consider time. So here also we have taken this one. Now for this, what we can write, this is equation. Now for the velocity v, if I write the velocity v, then what I can write, now delta psi by delta x, See this one, the velocity, which direction we need to consider? Now in the x direction. That's why the velocity I have taken here v. Now similarly, if I write u, then what will be there? Now that will be considered as a minus u, or you can write u equal to minus del phi by del y, or I can write minus u equal to del phi by del y. Okay, so these two things, what we can mention, equation 1. Keep it some equation 1 so that it will be applicable for the in the future equations. Okay, now we know that the continuity equation for the two-dimensional flow, Already I told you, this is very simple. Del u by del x, velocity with respect to x, u velocity in the x direction, plus del u by del v by del y equal to 0. Now here del w by del z no need to consider because that is 3-dimensional. Only 2-dimensional we can consider this one. So now we will put this value, this equation 1, that means u and v value in this equation. So what will get, substitute this value in this equation, what will get here? U value you can see that is a minus. So I can write del by del x. So I can write minus of this del psi by del y plus this is del v, del by del y, and this is we can write del psi by del x equal to 0. If you resolve this, what will get here? The minus of del square psi divided by del x del y plus del square psi divided by del x del y equal to 0. So this is the equation what we got here. So this, so you can say the existence of psi, suppose this is the equation what we got, this is 0 actually. Yeah, what we can say from this, the existence of this psi, that means the possible case of fluid flow. Okay, so the flow may be, we can say the flow may be rotational or irrotational, correct? So that is based on the conditions. So the flow may be rotational or maybe irrotational. For the rotational component, what we need to consider, the last, for this velocity component also we have seen, for the rotational component we can see that omega z, suppose, okay, omega z equal to, we can write 1 by 2 formula into del v by del x minus del u by del y, bracket close. Now what I'll do, I won't consider for other things like omega x and omega y. So only this one will put the value omega z. So here v is there and u is there. Just put this value of this in this u and v. So what will get finally here? Omega z equal to 1 by 2 bracket start. So del of del x. So what is the velocity of v? That means we have seen del psi by del x bracket close minus of del by del y, and this is again minus of del psi by del y and bracket close. If you resolve this bracket, or you can solve this equation, what will get finally? We'll get 1 by 2 delta square psi by del x square plus similarly we'll get here delta square psi by del y square. Okay, this is the equation we are going to get. Okay, for the rotational components. This is for the rotational component. Similarly, if I consider for the irrotational component, or irrotational flow, okay, I can say the omega z what we have considered, that should be equal to 0. Okay, that should be equal to 0. So for the irrotational flow, I can say the previous equation what I got here. Okay, this equation supposed to be like this equation will be 0. That means because this is the equation what we got for the omega z. So this omega z equal to 0 in the sense I can write the 1 by 2 is there. I'll take it to that side. So I'll get what? Delta square psi by del x square plus delta square psi by del y square equal to 0. If you see, this equation is nothing but our previous Laplace equation what we got. So now what we can conclude for this stream function for the psi, you can say the properties of this psi. Properties, two things will be there. As the psi need to be, it should be there here, flow should be there. So how we can say that the flow is there? For that also condition is there. Okay, so two conditions or two properties we can say. What is, if psi exists, if psi exists, then you can say it is a possible case of fluid flow. Okay, it is a possible case of fluid flow which may be rotational. It may be rotational or irrotational. It may be rotational or it may be irrotational. If you see in the previous one, velocity potential function, there only we have considered the irrotational one. Now here it may be rotational or irrotational is there. Now second one is there what? Now phi exists means, or phi should satisfy the Laplace equation. The Laplace equation. And it is possible, you can say, it is possible in case of irrotational flow. Okay, it is possible in case of irrotational flow. Okay, so I hope you understand like what is the theory concept of this stream function, and these are the two properties of the stream function. So let me again just give a brief idea about this. First things, we need to consider this stream function in two dimensionally, x, y, or you can consider yz or xz. So any two direction dimensional we need to consider. And what it says, the velocity of this fluid which is flows in any direction, that will be considered in the perpendicular to the others one, or right angles to the other one. That means the velocity of that fluid will be defined delta psi by del x. The velocity, previously what we used to give, now we use velocity with a proper direction, x direction we need to mention, only we need to mention with the negative partial derivative of that. But here we need to we need to consider the right angle of that particular fluid. Similarly, here you can say that is minus u, or you can say u equal to minus del psi by del y, but you write in this way, minus u equal to del psi by del y in the y direction. Okay, now next thing we need to consider the continuity equation. This is first step. Second, as per the definition, second step is we need to consider the continuity equation, because there is a flow is there, and for that we have to consider the second continuity equation for the two-dimensional flow. Just put these values on this and you'll find a equation here. Okay, so that flow should, whether the flow will be rotational or irrotational, that also need to be identified. So for the rotational component, I have taken a omega z and I found this one, this equation. Okay, if suppose the flow is irrotational, for the irrotational we need to consider the omega z equal to 0. Now, omega z equal to 0 means this omega z, what I got equation here, that's supposed to be 0. So I can write 1 by 2, I have taken that side, so it is 0, and del square psi by del x square plus del square psi by del y square. Okay, so this is the Laplace equation. So when it is satisfied, that means when the stream function satisfies the Laplace equation, we can say it is a possible case of fluid flow in case of only irrotational flow. Similarly, the phi exists means it is a possible fluid flow is there. It may be rotational or it may be irrotational. So this is the total concept of this stream function. If you have seen the previous video, then you can understand the velocity potential function, and you can find out the difference between this velocity potential function and stream function. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.